So hi guys, the last part of the question is, remember the flower that we have? This is the flower that we had, right? And it was positive charged, and there was a B in some altitude from the middle. This is, let's do it a little bit here, so we can draw B. And we found out that if we have positive charge, that the electric field is going upwards. But now I want to change something. I want to add, actually to take off the charge in the middle. So you can imagine that here the charge is distributed only here in the outside part, and in the middle there's no charge at all. So what is the electric field right now, the new one of this shape? How can I solve it? There's no charge in the middle, and let's be more specific. The radius of the flower is R. So until the middle, R over 2, there's no charge at all. So how you can solve it? So usually when I address this question to the audience, they tell me, it's easy, like we did in the previous tutorial, you just need to change the integral limits, right? To do it from R over 2 to R and not sum the dq in the middle, and this is right, they're correct. You can take this nasty integral again and try to fight with it and change the integral boundaries, but you can do something really simple. You can use the superposition. And what the superposition suggests you to do, to solve solve two easy problems and sum them up. So what we can do, we can take this solution that we already have, some radius R, positive charge, and we know what is the solution. The solution is some constant and a function of R, the radius of the flower. And we can also look at this similar problem. We have small radius, which is R over 2. This is with charge with negative charge, you see it? Negative charge. The solution of this electrical field is C, and the function is R over 2. Is a smaller flower kind of thing. And also, if this is negative, the direction of the electric field gonna be to the other side, right? To the negative Z. If this is a positive charge, test charge, you're gonna pull up to the negative. So I need to add here a minus, right? The direction is opposite. And if I'm gonna sum them up, I actually gonna have the problem of electric field with nothing in the middle, because the plus and the minus gonna cancel each other, and I'm gonna have the positive only in the outer shell, right? And this is what they actually asked me to do. So what I want you to do, and remember, I want you, when you solve questions, especially for the exam, you're gonna have a lot of the time multiple choice question, and you can see in the final solution that your solution is actually some superposition, okay? So I want you to think about that, about the superposition. If you can simplify some hard question to an easy question and not start from the beginning. And also I want you to always think about the direction. We talked a lot about the direction, that here it's only in the Z component, and the intuition to see that if your answer is right, you know, when you saw the direction of the forces and how you can simplify it. So you're gonna have in the homework a lot of 2D questions, but it's gonna be the same. Try to understand if the electric field going the Y direction, the X direction, the minus X, and try to sum up only the relevant vectors, right? So if you know that it's gonna be general in this direction, but the only thing that's gonna count out is E and X, try to sum only the E and X and not to solve the electrical field in every direction. So I hope this tutorial helped you, and I'm gonna see you next week. Good luck.